Dear students, today we'll discuss the problems on source transformation. So, I'll give the diagram. This is the diagram. You have to write here one current source. This is a current source, that is your 5 amps parallel with one resistance, and here it will be one resistance. Here there will be a resistance is connected like this. One, it is a dependent current source. This is our dependent current source. So parallel with the one resistance, and here like this, you have to connect one parallel with the one current source. So this is our 3 ohm, and this is the 7 ohm, and this is the 4 ohm, and this is 17 ohm, and this is 3 Vx, and this is positive, negative, and this is the Vx, and this is a 2 ohm, and this is 9 ohm, and this is the current, it is 1 amps. Calculate the current through 2 ohm resistor in the network shown in figure by using the source transformation method. In this figure, you have to calculate what is the current flowing through the 2 ohm resistor by using the source transformation. To solve this problem, convert this into a voltage source. This is your current source. This I have to convert it into voltage source. That convert it into voltage source. After converting this voltage source, again one more. This also I have to convert it into. That is also current source, that you convert into voltage source. So after converting the voltage source, you can write like this. V is equal to I into R, 5 amps, 3 amps, therefore it will becomes a 15 volt, and this resistance 3 ohms will come in series, 3 ohm, this is the 3 ohm, and this 4 ohm as it is you write, and remaining circuit you write, that is 7 ohm, it is there from here, that you have to write. Again, this is the current source, that is a dependent current source, that you have to convert it into voltage source. When you convert it to voltage source, you can write it as direction is like this, therefore you have to write here minus plus. So V is equal to I into R. I is 3 Vx, R is 17 ohm, therefore this becomes a 51 Vx. 51 Vx. This resistance, that 17 ohm, comes will be in series, that you write it as a 17 ohm. And again this 2 ohm resistance is there, that you write a 2 ohm resistance. This is the plus minus and Vx, and again this is also a current source. This also you have to convert it into voltage source. This also to convert it into voltage source. So when I convert it into voltage source, there is a resistance, it comes in series 9 ohm, and resistance, that is voltage source, you have to write this is minus plus, because the direction is like this, then it is a minus plus. If it is a reverse direction, then you have to write here minus plus. So this I have to connect it here. This is V is equal to I into R, 9 ohm into 1 amps, that will be 9 volt. So after converting this you have to simplify that. Now the circuit will be like this. This is our minus plus, 3 ohm and 4 ohm are in series, therefore it becomes a 7 ohm, and this 7 ohm is in series, that is a year in the parallel year, 7 ohm from year to year. This is your 7 ohm, right? And again remaining circuit right as it is. This is like this. This is your minus plus, and this is a 51 Vx. 17 ohm and 19 ohm are in series. That will become say 26 ohm and 2 ohm. This is plus minus Vx. 2 ohm is also in series, but he has to find out what is the current flowing through the 2 ohm resistor. Therefore, you have to retain this 2 ohm resistor. And the remaining voltage source that you have to write, this is positive, negative, and is a 9 volt, and this has to connect like this. Again, this is your, this is the, again it is a voltage source. This you have to convert into current source. This you have to convert into current source. So that value will be, so this is your previous, that value is a 15 volt. Now we convert this into current source. After converting the current source, this is I is equal to V by R. That is V is 15 volt and R is a 7 ohm. Therefore, that is 15 by 7 amps. And that 7 ohm, this 7 ohm will comes in series. That is sorry, in parallel. This is where 7 ohm, and this 7 ohm right as it is. Remaining 7 ohm right as it is. This is the 7 ohm, and this is the another voltage source. This you have to write as it is. This is the minus plus. This is the 51 Vx, and this will be a resistance. It is at 26 ohm, and again this is 2 ohm plus minus Vx, and this is the 2 ohm, and this is your plus minus. This is the 9 volt right as it is. Now you can further is simplify here. This 7 ohm and 7 ohm. This 7 ohm are in parallel. This 7 ohm and this another 7 ohm as are in parallel. Then what is the total resistance at right? So this becomes, again you have to write it is, so this is where the current source, that is 15 by 7 amps, and this resistance will be comes in parallel. This is your 3.5 ohm, and this is the your remaining circuit. You have to write it is, this is 51 Vx, and it is 26 ohm, and here it is 2 ohm, and this is the positive, negative, and this is the Vx, and this remaining voltage is plus 9 volt. Okay, right like this. Again to simplify again network, this is a, again the current source. This I have to convert it into voltage source. Again this I have to convert it into voltage source. After converting the voltage source, so we can write it as a voltage source like this. This is where minus plus V is equal to I into R. So that is 15 by 7, 15 by 7 into 3.5, that gives you 7.5 volt. 7.5 volt, that resistance is 3.5 ohm, that will comes in series. And again it is, so remaining dependent voltage source you have to write it is 51 Vx, and 26 ohm resistance is there, that you have to write another resistance. It is plus minus, this is the Vx, and this is the 2 ohm you have to write as it is, and here it is plus minus, this is the 9 volt, and you have to write this remaining circuit like this. In the problem he has asked what is the current flowing with 2 ohm resistor, and this becomes a loop. Assume the loop current I, apply the KVL. What is the KVL? KVL is nothing but algebraic sum of the voltage drop across each element will be 0. So now apply the KVL, Kirchhoff voltage law. Kirchhoff voltage law, that is algebraic sum of the each element will be 0. The algebraic sum of the voltage drop across the each element will be 0. So I'm moving like this. Therefore, it will be first it is a minus sign. Therefore, it take a minus 7.5 plus. This is plus minus plus minus plus minus. Because I'm moving like this, I consider as a voltage drop. So what is the drop across this resistor? That is 3.5 I. V is equal to I into R. So therefore it is a 3.5 I minus 51 Vx plus 26 I, okay, plus 2 I plus 9 is equal to 0. So but what is the Vx looking from the diagram? But Vx is equal to voltage drop across the 2 ohm resistor. Therefore Vx is equal to 2I. So therefore the above equation becomes minus 7.5 plus 3.5I minus 51 into Vx is 2I plus 26I plus 2I plus 9 is equal to 0. So this will becomes minus 70.5 I is equal to minus 1.5. So therefore I is equal to 1.5 divided by that is 70.5, that gives here 21.28 milliamps. Therefore the current it is flowing in a 2 ohm resistor is 21.28 milliamps. Take this one problem. They're asking a problem like this. So this is here they're connected one resistor. From here it is connected another resistor like this, and here there will be a one more resistor, and it is connected to one current source. So like this, and here it is. This is another voltage source, and here that be connected one resistor, and here it is one more resistor, and this is the point it is A, and this is the point it is B, and this is our 2 ohm, and this is the 5 ohm, and this is 45 amps, this is 8 ohm, and this is the 10 ohm, and this is 30 volt, and this is 3 ohm, and this is the 6 ohm. The question will be asking like this: reduce the network shown in figure to a single voltage source in series with a resistance using source shift and source transformations. So in this, you have to, this is the current source. You have to shift this current source to these two resistors, that is 2 ohm and 4 ohm. And 30 volt, this you have to shift it for this, shift the source for this resistance. Then we can write a diagram like this. So this is where the current source. So this is the resistance. It is connected like this, and it is connected at this point and this. Therefore, retain this end and remove this end and connect it here. So you can write a diagram like this. This is where this, and one more resistance it is connected here, and here you shift the source. So you can write like this. This is already disconnected this end, retain the same end. This is, it is retained the same end, and it is connected to this point, it is A, and this is the 5 ohm, this is a 2 ohm, and this is 45 amps, and this is also 45 amps. It is connected already this end, retain this end, remove this wire and connect it to 5 ohm. Then the circuit will be appears like this. and shift this 8 ohm. This voltage source you to shift this here. This is a positive negative, and again it is negative positive, and so resistance it is so connected here. Okay, and here there will be a one resistance, and it is connected to here this resistance. You can connect like that. This is the point, it is B, and here positive is connected to 8 ohm, positive is connected to 3 ohm, that is here 3 ohm, and this is 6 ohm, and this is the 10 ohm. Negative is grounded. You take the same point and it is connected to this point. Negative negative connected to this end. Okay, now you can shift convert this. This is your again. Further, if you want to simplify this, you can convert this. This is a current source converted into voltage source. Again, this is a current source converted into voltage source. So after converting this, we can write a diagram like this. That means this becomes here. There will be a one voltage source. So after converting this, we can write a diagram like this. There will be a one resistor, and this is positive negative. This is 90 volt, and the resistance is 2 ohm, and again it is here positive negative. Another it is a this is 225 volt. V is equal to I into R, and this is the resistance. It is a 5 ohm, 90 volt, 2 ohm. Retain right remaining resistance. It is 8 ohm, and here it is again the 10 ohm, and remaining that the voltage source is right as it is. This is plus minus. This is the 30 volt. This I already shifted, so you can write it like this. 8 ohm. So here they written as a plus minus. This is for 30 volt, and here it is minus plus, that is 30 volt, and there will be a resistance here, and this is 5 ohm, 10 ohm, and this is 6 ohm. This is 6 ohm, and this is 3 ohm, and this is the point, it is a B, and here it is shorted. These two pointed shorted here. In this figure again, 8 ohm, 2 ohm are in series. Okay, and this is the point, it is B. Here the point, it is A. This is the node, and this is the point, it is A. 8 ohm, 2 ohm are in series, 5 ohm, 10 ohm are in series. That you simplify. So here minus plus, okay, plus minus, different direction. Therefore you can subtract. So the voltage will be, here it is minus plus, and the resistance will be in series. This becomes 60 volt, and this resistance it is 10 ohm. Okay, again here the voltage source it is positive negative. This is 225 volt, and resistance it is 15 ohm, 15 ohm, and you connect this point. Here it is minus plus, and the resistance it is right, and this is the point B, and this is our 30 volt, and this is 3 ohm, and this is 6 ohm, and this is a point, it is B. Again further, if you want to simplify, again you can convert this. Okay, these are the voltage source now here. This you have to convert into current source, and this also you have to convert into current source, and this also convert into current source. So after converting, you can write like this. So this is the point, it is A. This is the point, it is A. The same point. Again you convert this. So current source, you can write a direction like this, and this resistance you have to write. This is your 10 ohm. This is I is equal to V by R. This is 6 amps. This is will be I is equal to V 6 amps. Again here the direction is like this. This is 225 by 15. How much? This is 15 amps. 15 amps, and then this resistance comes in B parallel, that is our 15 ohm. Okay, again from this point, again this converted again this into current source, so we can write like this, and here there will be a resistance, it is 3 ohm, and this is I is equal to V by R. This is your 10 amps, and this is the 3 ohm. Another resistance, it is connected to this point and this, so we can write it is 6 ohm, and this is the point, it is B. This is our 6 ohm. Now we can see that here. So 15 amps and 6 amps are in different direction. This becomes a 9 amps, and 10 amps and 15 amps are in parallel. That will be 6 ohm. So this, after this you can write a diagram like this. That piece here you can convert this. So this is 10 ohm and 15 ohm are in parallel. After simplification you get a 6 ohm. 15 amps and 6 ohm are in opposite directions. You can get a subtraction, you get a 9 amps. And 6 ohm and 3 ohm are in parallel. Calculate what is the total resistance. That becomes 2 amps, and this is the 10 amps. So after simplifications, so we'll get a circuit like this. So you're getting, this is positive, negative, and this is the 54 volt, and there will be a resistance, that is 6 ohm. Again it is minus plus, this is 20 volt, and this is the 2 ohm, and this is the B, and this is the point, it is A. Now plus minus minus plus are different direction, so that you can subtract here. This is our 34 volt and 6 ohm, 8 ohm are in series. This becomes, it's a 8 ohm, this is a point, it is A, and it is A. This is the final network after simplification by using the source shift and source transformation.